Hello, everyone. So today, my goal is to debunk some of the neuroscience facts that go around. Neuroscience is extremely trendy these days, but with that comes a lot of misinformation. And so hopefully you will find this video interesting. One of the ideas that people get wrong about how the brain works is that they believe that the human brain detects reality as it is. But in fact, the brain is much more so a predictive machine. It is trying to create and predict what is going to happen instead of actually detecting what is happening. And so a very useful idea behind this process is called the Bayesian brain, which is based on Bayes' theorem, which is the idea that the brain, through experience, has prior assumptions about what will happen in the future. And so what the brain is always trying to do is to update the current model of experience based on prior experiences and also on new information that comes in. And all of this process is tuned by prediction errors. So sometimes the brain makes a prediction which is wrong. And because of that, it will over time adjust that prediction and try to make it more accurate. The brain also privileges predictions that are more similar to past experiences. So the priors that are inserted in this conceptual model of experiencing the world are extremely important when it comes to understanding what the brain will predict in a given scenario. The second thing that many people get wrong is the idea of neuroplasticity. And so neuroplasticity is essentially the ability of the nervous system to adapt to changes in the environment. And the thing here is that normally people discuss neuroplasticity as being an absolutely positive thing. But the fact is that neuroplasticity can also be extremely negative. And for example, if you look at trauma responses, which are essentially defined as maladaptive forms of plasticity, we can see that this ability that the brain has to rewire and adjust to experience can very easily go in a negative direction. And so this is why trauma and a lot of mental disorders tend to happen in the phases of our life where our brain is at its most plastic state. Because with additional plasticity, there also comes vulnerability. And so this is something that we need to keep in mind, that and even therapeutically, that plasticity isn't always good because there's always that potential for there to be maladaptive plastic responses. Another aspect which many people get wrong about the brain is the idea that the brain has no inbuilt capacity to regenerate. And I mean, this isn't totally wrong because neurons are for sure, they have a far lesser ability to regenerate than, for example, other cells in our body, such as liver cells and blood cells. But it isn't absolutely correct that that neurons do not have the ability to grow and develop and regenerate even when we are adults. And so for a very long time in neuroscience, there was this dogma regarding adult neurogenesis. And so neurogenesis is just a fancy word to basically represent this idea of the birth of a neuron, so the growth and the development of neurons. And so this dogma was started to be challenged in the 1960s by Joseph Altman, and later on the findings of Joseph Altman were supported by Michael Kaplan. But in the case of Joseph Altman, when he started saying that perhaps there was some form of neurogenesis even in adult populations, and first of all, the insights for this possibility came from studying birds, the hummingbirds. And so this idea that the human brain or that the animal brain had any ability to create new neurons even as an adult was seen by many as a career-ending statement. That you were seen as crazy by even suggesting that was a possibility. And in the case of Joseph Altman, he was extremely criticized by the rest of the scientific community, particularly by people such as Pasko Rakic. And so as you can see, this is a statement that was extremely controversial. But what was found out is that indeed the human brain can engage in neurogenesis, although in adults, although that neurogenesis is of course limited. And there are two regions in the brain that neurogenesis in adults can be observed. One of them is in the hippocampus, which is a very important region of the brain relating to memory. And the other region of the brain which neurogenesis can also be found is in the amygdala. And so many of you know the amygdala as the fear center of the brain, although the amygdala has many other functions, not just that one. But if you think about it, it makes a lot of sense that a structure that is participating in fear responses, which from an evolutionary standpoint are extremely important because fear is supposed to be something that keeps us alive. And so the fear learning, the ability to really remember fearful situations and dangerous situations is extremely important. And so given that that's such an important aspect of survival, or at least it was until modernity, it makes sense that the amygdala has this ability to regenerate itself or grow in dimension and develop perhaps in ways that other brain regions do not have the ability to do so. And this, of course, has a critical consequence because it means that this ability to, once again, incur in this plasticity, because neurogenesis is an important aspect of neuroplasticity, that we have a structure such as the amygdala, which has this ability to generate new neurons, although a limited ability, means that maladaptive responses may happen. Another problematic aspect of pop neuroscience is this idea when we mix up quantum physics with the brain. And to be more specific, I'm not talking about, for example, the work of Roger Penrose and the idea that, for example, consciousness is an emergent property of quantum phenomena at the level, for example, of the microtubules. But what I'm saying is that many times in pop culture, we like to mix up these words such as quantum effects and observer effect in ways that are that go against the term of art, which go against the very strict definitions that we have built up to even engage in this discussion. And so what I mean by this, and I will give a concrete example, is that a lot of times people talk about the observer effect, which is related to the idea that somehow consciousness interacts with the environment and generates a collapse in the wave function. And people talk about this, for example, by saying that, for instance, I'm picking up this cup, and this cup only exists because I perceive it. And so my consciousness is generating this cup somehow. There is a physical interaction between my consciousness and the physical environment around me. And of course, this can get very philosophical, and it might very well be true. In fact, I'm extremely agnostic and open-minded regarding the possibility that the universe is far weirder than we take it to be, and I'm extremely agnostic in terms of how the brain interacts with the reality around us. The very important part here is that when people say that the objects around them are being created by their minds, they're not talking about it in a subjective sense, in the sense that they are having a perceptual experience. They're actually saying that their perception of the world has a material, physical implication in how this, let's say, hidden material world actually works. And so the problem when people talk about the observer effect and claim that it is a way that it proves that the brain changes physical reality around it through consciousness, is that the problem here is that the changes that we are seeing in this experiment, in the double slit experiment, is mainly due to a physical manipulation. So through the instruments that we are using, we are actually physically changing the observation. And so it isn't correct to say that it is consciousness which is creating the collapse of the wave. It is more so the idea that we are actually interfering, right, with the phenomena that we are observing through the instruments that we are using to measure them. And so, don't get me wrong, there is for sure a possibility that our minds are interfacing with a material reality in ways that we have no idea about it. And it is possibly true that this underlying principle that these people who are claiming that these experiences in quantum physics are symbolizing could be true, but using this particular experiment as a justification for that doesn't seem to be a very correct way to do it. So we need to find different ways to talk about this idea of how consciousness interfaces with potentially a material reality. Another thing that many people don't know about the brain is that you can actually live with just one brain hemisphere. And so, as you know, we have two hemispheres, the left and the right hemisphere. The left hemisphere tends to be the hemisphere where our language centers are located on. So we tend to have a left hemisphere dominance. So dominance basically refers to where your language center is. And this is the case for most of the population. One good way of predicting what hemisphere is dominant in you is what is your dominant hand. Although there are also cases where you may have people who are left-handed, but they're still left hemisphere dominant. This idea that we need the two hemispheres has been also disproven. There are cases where people actually live their whole lives. They're born with just one hemisphere, or they lose one hemisphere due to a stroke, but they don't realize it. And one day they go and have a brain exam for an unrelated matter, and they realize that they're just operating with one hemisphere. And so this just shows the brain's amazing ability to rewire itself and actually use existing circuitry to do other functions. And so the brain is actually able to repurpose existing functions, existing circuitry to do functions that circuitry hasn't done before. And of course, this process of rewiring and changing the way the circuits are working is easier the younger the person is, because once again, it's the younger you are, the more plastic you are, so the greater the ability that the brain has to change itself and adapt to different circumstances. But this is something that many people don't know. And then something which is also important to mention is that when people talk about brain hemispheres and they say, oh, you're a left hemisphere person or you're a right hemisphere person, I think we're giving too much emphasis on the differences between the two brain hemispheres, because in actuality, they're actually pretty similar. Both hemispheres can essentially do the same function that the other one does, although they're better at certain specific functions. So, for instance, when you talk about the left hemisphere, we're talking more about mathematical reasoning, we're talking about language, we're talking about sense making, while the right hemisphere is more about abstraction, aesthetic perception. So let's say we can say that the right hemisphere can be characterized by a more mindful identity, while the left hemisphere is the certainty-seeking, let's figure all of this out through mathematical reasoning identity. But in reality, they are extremely similar. They just have some differences in their specificity. And so I don't think we should we should not enter this idea that they are radically different. Another thing that most people don't realize about how the brain works is that the brain is fully dependent on the body, at least as far as we know. And this is where we have the concept of embodied cognition. And so this is where you also have some researchers which argue that the brain simply exists to model a body. We can debate that. It seems rather plausible that the human brain is dependent on the body and that it uses signals from the body to gain information about the external environment, and the body is also very important in terms of decision making, signals from the body. And so this is where you also have the work of Antonio Damasio about somatic markers, in which the brain uses these sensations, these visceral sensations, emotions, as a way to make decisions. And so I'm just mentioning this because a lot of times we tend to live in this duality of having a brain and then having the body, and that we are always up here and then the body is part of the rest. And so I just think that we need to be aware that this is a fully integrated system. Another thing that most people don't realize about the human brain is that memories aren't exact representations of what actually happened. And we have some studies in cognitive science that show that every time we recall a memory, there are some constructions that are added to that same memory. So this means, in a way, that every time we recall a memory, there is a greater chance that we are getting more distant from the original memory. And if we consider the original memory to be more representative of what actually happened, then we can argue that every time we recall a memory, we are actually getting further away from what actually has happened. And so another thing is that when we are discussing memory, most people like to mention the hippocampus, but what we also need to refer here is that the hippocampus plays a significant role in terms of the declarative and episodic memory, so the ability to recall an event and actually discuss details about what actually happened and being able to have a semantic representation of that event. But when we talk, for example, about other types of memory, or when we talk about, for instance, long-term memory, although the hippocampus plays a role in terms of the consolidation or at the processing stages of long-term memory, it doesn't actually serve as the final storage site. So actually, when we are discussing long-term memory, these memories that we hold, we cannot actually really know where they are. They're basically spread out throughout the cortex. And so this is also just an additional detail when it comes to the way most people talk about memory and neuroanatomy. Just to add another detail, when we were talking about procedural memory, which is basically skill-based, so for example, skills and habits, for example, the ability to draw certain objects or some motor tasks, so the actual memory, the ability to do those tasks, isn't also done by the hippocampus. Another thing that I often hear about the human brain is that many people believe that the brains of our ancestors, thousands of years ago, even not that far away ago, such as, for example, in medieval times, that their brains were different than ours, and that our current brains are more developed and better than the ones of our ancestors. And this is actually wrong, because, as you know, biology takes a very, very long time, and our brain has remained basically the same for many thousands of years. Although there is this trend, based on archaeological findings, that the human brain has been getting smaller and smaller. And this trend has been observed from 100,000 years ago. And there are several theories for why the human brain might be shrinking. One of these theories is that with the advent of language and with more abstract ways of thinking and with our use of symbols to represent the world around us, this additional element to our neural circuitry needed more, due to its metabolic demand, we needed the brain to become more efficient. And so this shrinking of the brain might be just the consequence of some pruning process in which the brain has been able to become more efficient, and so this shrinkage might be a consequence of the brain basically updating itself. And although this might be a reasonable theory to explain this phenomena, it is important to mention that there is no conclusive idea for why this might be happening. But even though we have noticed this pattern in terms of the decrease in the size of the human brain, when we talk about the structures and the anatomy in it, our brains are basically the same as they were before, and especially our brains are basically the same as they were when we talk about our medieval ancestors, or when we're talking about 2,000 years ago. And so this idea that our brains are better right now is not a correct notion. It's more so a consequence of presentism. And so we need to keep that in mind. Oftentimes we also, when we discuss medieval times and the way people lived back then and the beliefs that people had, oftentimes we forget that if we were born in that exact same medium, we would most likely have the same beliefs as those people did. And so it's not that we are more intelligent than the people in those times were. It's that we just now have more information. And because we have more information, we're essentially able to operate in a different way and to reform our beliefs differently. It is also the case that when we discuss intelligence, oftentimes we confuse intelligence with knowledge. And so what we have these days is that many people, due to their exposure to social media and to the availability of information, they actually become very well aware of many facts about the world and many ideas. But when we talk about intelligence, the ability to problem solve, the ability to reason, many of those people aren't actually that good. And we can argue that the ability to reason is actually something that we might see a decrease in. And there are very many reasons for that. We do not have necessarily data to back this up. So I'm just laying out a theory, which is that our increasing reliance on technological aids to do our work, for example, the use of ChatGPT to write essays, the use of calculators, the use of many of these instruments that are perhaps being done in overly generalized ways, are essentially making us less able to reason, because we are basically becoming dependent on external tools to develop these cognitive skills. And so one very easy example regarding this is arithmetic. And so what you normally see with people who haven't been to school for a very long time and that they don't use numbers on a regular basis is that your ability to do simple arithmetic operations, adding, subtraction, multiplication, all of that, you basically sort of lose the speed that you had when you were, for example, in school. And so I believe that this will also happen with many other things. The fact that we have information that is so readily accessible is basically making us become less able to engage in certain cognitive functions. But I will dedicate the whole video towards that. But so overall, I think these were some of the myths or maybe ideas that are represented in mainstream pop culture of neuroscience that I wanted to clarify. And so hopefully you found this video to be useful.